Finding the molar mass of a compound is often the first step in more complicated chemistry problems. When we say molar mass, we mean the mass of 1 mole of that compound. Sometimes it's called the gram molecular mass. I'll also explain what is meant by gram formula mass. That's a lot of terms that all sort of mean the same thing, so it's no wonder people get confused. We'll work through 5 examples. You'll need the formula of the compound and a periodic table to know the gram atomic mass of each atom. Here's our first example. What's the molar mass of water? We could also say, what's the gram molecular mass of water? Because water is a molecule. We're trying to find what's the mass of 1 mole of water molecules in grams. The formula of water is H2O. To calculate the mass of 1 molecule of water, you would add the atomic masses of the 3 atoms that make up 1 water molecule. But we don't want the mass of just 1 molecule of water. We want the mass of 1 mole of water molecules. By the way, we have a short glossary video about the mole if you need a refresher for that definition. 1 mole of hydrogen atoms equals 1.0 grams of hydrogen. I got that from the periodic table. We usually go to 1 decimal place for these calculations. 1 mole of oxygen atoms equals 16.0 grams of oxygen. Again, that's from the periodic table. The molecular formula of water is H2O, which tells us there are 2 moles of hydrogen atoms and 1 mole of oxygen atoms in 1 mole of water molecules. Let's add that all up. In 1 mole of water molecules, there are 2 moles of hydrogen atoms times 1.0 grams of hydrogen per 1 mole of hydrogen, moles cancel, equals 2.0 grams, and 1 mole of oxygen times 16.0 grams of oxygen per 1 mole of oxygen, moles cancel, equals 16.0 grams. We add them together and get 18.0 grams per mole. That's the molar mass of water. We can also call this the gram molecular mass of water. Let's do another example that is similar. What's the molar mass of glucose? The formula for glucose is C6H12O6. Look on the periodic table to find the gram atomic masses for all of the atoms in this molecule. Carbon is 12.0 grams per mole, hydrogen is 1.0 grams per mole, and oxygen is 16.0 grams per mole. Multiply by the number of each atom like so. 6 times 12.0 plus 12 times 1.0 plus 6 times 16.0 equals 180.0 grams per mole. That's the molar mass of glucose, or you may hear it called the gram molecular mass. Sometimes you'll hear the term gram formula mass instead of gram molecular mass. What's the difference between these two terms? Both are molar mass. You calculate them in the exact same way. But gram molecular mass refers to compounds that are molecules, like water and glucose, things that are held together by covalent bonds. Gram formula mass refers to ionic compounds. Table salt, for instance, NaCl, that's an ionic compound. And the representative particle of an ionic compound is called a formula unit, as opposed to a molecule. Hence the name gram formula mass. So let's do one of those, and you'll see it's really the same kind of problem. If someone asks you for the molar mass of table salt, or they ask you for the gram formula mass of table salt, you need, once again, the same 2 things: the formula of the compound, NaCl, and a periodic table to look up the atomic masses. There's 1 sodium ion and 1 chloride ion in each formula unit of NaCl, so there's no multiplying involved here. Gram atomic mass of sodium, 23.0 grams per mole from the periodic table, plus gram atomic mass of chlorine, 35.5 grams per mole, again from the periodic table, equals 58.5 grams per mole. Let's do a couple typical applications where you would use the molar mass in chemistry problems. How many moles of water are in 50.0 grams of water? Earlier, we calculated the molar mass of water, 18.0 grams per mole. We're going to use this as a conversion factor. If you're a little uncomfortable with the idea of using conversion factors, please watch our 2 videos about unit conversion and dimensional analysis. They tell you all about using conversion factors and this style of problem solving. We start with what we know, 50.0 grams of H2O on the left. Leave a big space, and write what we want on the right, some number of moles of H2O. We multiply 50.0 grams by a conversion factor to get to moles of water. Our conversion factor will have grams of H2O and moles of H2O in it. That's the molar mass. There's 18.0 grams in 1 mole of H2O. We'll write it as a fraction equal to 1. So our conversion factor is 18.0 grams per 1 mole. But remember, we have to be careful to put that conversion factor in the right orientation so the units will cancel. If we write it as 1 mole over 18.0 grams, then grams cancel. Multiply across the top and multiply across the bottom. 50.0 grams of H2O times 1 mole over 18.0 grams, grams cancel, equals 50.0 divided by 18.0 moles of H2O. This simplifies to 2.78 moles of H2O. A combustion reaction consumes 12.6 moles of glucose, C6H12O6. How many grams of glucose is that? Start with what you know on the left, 12.6 moles of C6H12O6. Leave space for your conversion factor. Now write what you want in your answer, some number of grams of C6H12O6. We need a conversion factor that will take us from moles of glucose to grams of glucose. We can use the molar mass of glucose to do that. The molar mass of glucose is 180.0 grams per 1 mole. We calculated that in example 2. We'll write that as a fraction equal to 1 to use it as a conversion factor. 180.0 grams over 1 mole. Be careful with the orientation of the conversion factor so units will cancel. 12.6 moles C6H12O6 times 180.0 grams per 1 mole, moles cancel, equals some number of grams of C6H12O6. Multiply across and you'll get 12.6 times 180.0 divided by 1 equals 2,268 grams C6H12O6.